Okay, so today I'm gonna show you how to use the new LabChart to analyze your data. And so I'll be using one of my participants' data. So I have it in this training folder, and we're gonna open it up. So this is quite different from the one that we have, or like the tutorial that we have. This is the newer one and has all this channel. So there's a couple of things you have to do before you start running the macro. And so one of the first things you want to do is see what the comment keys are. Because of the way it is set up in MATLAB, this app that we use to look at the data, you have to make sure that the comment keys are as start, standing, and end. So not starting, standing, and end, but start, standing, and end. If it's any different, what you want to do is click on the comment key, edit, and then put it to look like this. So start. If it's starting, then it's not going to work on MATLAB. So you want to keep it at start. So we want start, standing, and end. Okay? So that's the first thing that you do. Second thing you want to do is you want to expand. So I like to keep it at 10. One thing that you want to do is auto scale the data. So you want to see all the channels in the line. So just right click on your mouse and auto scale data. So I just like to do that for everything. Skip this one. Like so. Then you want to come to the systolic and diastolic pressure channels, and you want to change where how the peaks are calculated. So we want to make sure it's recognizing every of these peaks. So when we go to the systolic channel, you come to cyclic measurements, and we can see that in some cases it's the detection of the peaks is not clear for everyone. You can see very well here. It's missing that. It's missing that. When there's calibration, that's fine, but you want to make sure that it's seeing everything. And so what I like to do is come to the preset and change it from finger pulse. You click on that arrow and change it to arterial pulse, arterial pressure, and you can see that now it detects every single peak. That way, when you put it into LabChart, it's when you analyze the data and run the macro, it reads every single peak, what the numbers are. And so you click OK, and that automatically changes it for the diastolic. So you see like arterial pressure, okay, and then the mean arterial pressure. You want to make sure it's also arterial pressure. So we want to auto scale again so we can see everything, and you can see that it's detecting more of the peaks, and that's what would have an effect on your height corrected systolic and diastolic once it minuses the height corrected units. And so I go all the way to the top, so to the start, and auto scale again. Like so. And what we want to do next is calibrate the waves so that they match what we recorded in the lab. So that's why we have the manual measurements that we do, and we write it down in the Excel form. So we can see for this participant, make sure it's the same name. Our blood pressure when she comes into the lab is 117/82. But if you look here, it's reading as, so if you look at the numbers on this side, it's reading as 148.95. So we have to change that. And so what you do is you select this. So you click on the mouse and you select a couple waves. Maybe we should skip that one. So you select this. Oh no. Like so. And then you come up to finger pressure, come up to unit conversion, and we want to change that way to read as what we saw. So we said 117.82. So sorry, 1 second. 117.82 right here. And so we want to pick the top part and click this point, like this arrow, and change it to 117. And then we want to click the lowest part, so that will be your diastolic. Put it here, 82. 82. And then you click OK. And what that does is that it calibrates it to being close to the numbers that we actually got manually. And so if you look on the side here, it's changed from that 152 to 120. The next thing we want to do is the cardiac output channel. So because there are two models in which cardiac output can be um, calculated, one through the Windkessel model and one through the Lightstrand model. The Windkessel uses the age while the Lightstrand doesn't. And so we want to see which one is best, because sometimes for each participant, it depends on the detection of the waves. So what we do is see the readings in general. So I like to put this more to like maybe 20 and then see what the readings are and compare the two. So we're looking at the numbers on this end. And so we can see with this model, it's saying that during the parts where it's not calibrated, so 1.6, 1.6, 1.7, 1.7, 1.7. So it's fairly similar throughout. And then we can compare with the other one. So you right click, you click on the arrow, not right click, you just click on the arrow, go to non-invasive cardiac output, and let's see how it looks like with the Windkessel model. So with the Windkessel model, there's a lot more variations. 1.7, it's a bit higher up. 1.72, 1.7. And the reason why we do this is that sometimes some people, it would read as, depending on the model you use, it would read lower or higher. So we want to see what the trend, so this 1.7. So this one doesn't really change, which is fine. So you can use whichever model. This one's really low, 0.9. Let's see what it looks like with the other. We want to look at the one that physiologically makes better sense. Wait a second. Oh my, okay. Let's click. Okay. Lightstrand. And then we'll see if it's higher. It's a bit higher, so we'll keep this one. We just don't want values of 0.9 because that doesn't make sense physiologically. Yeah, and so we'll keep it to this model. And it doesn't change much during the baseline, which is good. Okay, so now that we have that, the next thing that we want to do is go onto the data pad. So we go to this data pad view, and you click this first icon there, which is data pad view. So what I want to do is change, because we're using a different template from the old phenometer to the newer one that we're using. We want to change where it's getting its data from. So the selection start, we can see right now it's in minutes and seconds, but in MATLAB it only recognizes milliseconds, so we have to change that. So it only recognizes seconds, sorry. And so we want to right click on this and then go to format cell. We come to time and we change the time to duration in seconds. And what that does is it changes the minutes, seconds to only seconds. And so you do that for the selection start, so column A, and also column Q, so the comments time. So you want to right click on that, format cell, time, and duration in second. Okay, then what we want to do is change the finger pressure maximum and minimum. Right now it's getting it from the finger, so if we go back to the chart view, it's getting from this finger pressure measurements, and we wanted to get it from the eye corrected systolic and diastolic and mean arterial pressure channels. So what we have to do is go back to that data pad view, and then we right click on the finger pressure maximum, go to column setup, and you can see that it says statistics maximum value, which is your systolic blood pressure, and it says calculate from source channel finger pressure. We want to change that to eye corrected systolic, right? And then we want to go to selection and active points, go to value, and also change that to eye corrected systolic pressure. Sometimes it goes automatically, sometimes it doesn't, so you want to make sure that you're doing that, making sure that both are set to eye corrected systolic. Then one thing I like to do, because I don't like too many numbers, I go to the format and then I just change it to 2 decimal points and I click OK and then OK. And what it does, it takes that measurement from the eye corrected systolic systolic channel, number channel. You do the same for the finger pressure minimum. So you right click on that column setup, minimum value this time around because you're taking the minimum value and you change that to eye corrected diastolic. Go back to selection active point value, make sure that it's in eye corrected diastolic. Then if you'd like, go to format. It just makes the table look cleaner when you export it as a text file, which is why I like to just put it to 2 decimal points. And then OK and OK. And then you do the same for the mean arterial pressure. So right click, column setup. Now it's going to be in mean. And then you change it to mean arterial pressure, selection active point, value. Make sure it's mean arterial. Then I get format, this, OK, and OK. Then again, I just like to keep all of the other all of the other columns cleaner. I don't like when it has, like, for example, this column here has like 7 decimal places. I don't really like that. It just makes the text file look janky. And so I just change everything to 2 decimal points. So I start with my cardiac output, format cell. I don't have to go to column setup for this one because it's directly going to get it from that channel. And then 2 decimal point. Okay, I don't touch heart rate. Heart rate is fine. Then I go to CPER, do the same, format cell, 2 decimal point. Stroke volume, because it's in its thousands, I like to do something different here. So I do format cell, keep it the same, 2 decimal point, but you can see that it has a comma, and when it has a comma, it doesn't get recognized in the MATLAB. So I come to fixed category and then I uncheck this use thousand separator to remove that comma and just click OK. And it goes like that. I'll show you how it would look like if we don't go to fixed with this channel, the DP channel. So if you right click on that, format cell, let's say I don't go to fixed, it's going to look like that, and that doesn't get recognized on MATLAB. So it has to be without the comma. So you can right click again, format cell, then go to fixed, and then remove that 1000 separator and have it like that. For the CI, we need something called the BSA, and the BSA is something that you calculate using the height and weight and 0.71345, which is the Dubois calculation. And so if you'd like, you can just calculate that, get the participant's weight, get the participant height, and calculate it. But an easier way for you to do that is to use this site that I found, or that is online, honestly. You can just do body surface area calculator, and the formula you want to use is the Dubois formula, and it's this 0.007184 multiplied by weight to the power of 0.425 multiplied by height to the power of 0.725. And you can do this on your own, or you can just plug the numbers into this calculator and it gives you the same. I have tried it. So for this participant, I have their weight and their height. So their height is 170 and their weight is 58. And so you come here, you put 58, which is already there, and 170, which is there, and then you just press calculate. And then 169. You want to make sure that there's nothing in the feet and inches, or else it's going to continue using that instead of the centimeter. So you want to make sure this box, the feet and inches, is empty. And you want to make sure it's only in the centimeters. And we can see using the Dubois formula, it's 1.67 meters square, which is what we need. We don't need the feet square or the inches square measurements. We just need the one in meters square. So 1.67. I have a column in the file for BSA, so if you want, so you don't have to go up like back and forth. So I just put it there, 1.67. And so we take that number and we just input it into this column. So F1 divided by 1.67, and that gives you your number. Here I also like to change it to 2 decimal places by using that format cell. And then this one also, format cell, custom, so it's in custom, not general. two decimal places, and okay. And that's it. So that's all the setup that you have to do before you start doing your macro. So now that that's done, we have to figure out how we do the macro. So to do that, we come up to the start and we have to choose a peak here. Okay. So this is where it starts. We have to go maybe 2 or 3 peaks before. So you have to click on the number here, like so. And then depending on the laptop that you have, you'll either use Control F3 or Control Function key F3 for this part. So for my laptop, I use the Control Function F3, and I press all at the same time, and it gives you this little gray box. And what this is doing is making sure that the peaks are all detected. Sometimes it doesn't get detected, and you have to change the threshold, and I'll show you how to do that in a little while. Usually the threshold that I use is 5%. So if you come to the commands key, you can see find. So it says Control F, but for me, I like to do Control F3. So depending on the computer you have, Control plus function plus F3 might work. So you come to find, and the threshold that you use, 5%, will determine what peaks are being recognized. Sometimes if there's a lot of noise, you have to increase the threshold so that it only detects the peak. But just looking at this, we're going to try using the 5% threshold. And what you want to do is you want to go through the entire document manually to make sure that there's nothing being missed. And this is where it kind of gets a little boring. So what you want to do, Control F, function F3 for me, you just keep pressing you hold your Control key down and press your F3 key, like as it goes one by one. Okay. Or if you have your control function F3, you want to hold your control function key down and then click on the F3. So we're going to go through the entire document. You would notice that when we get to the point of calibration, it gives this big gap. That's okay. You just want to make sure that the waves, it's actually reading the waves. Also, when you collect data, and this should be something that you do before the participant comes in, you want to make sure that after you've set up the participant, you wait at least 1 minute so that the calibration is not there's not too much of a calibration. So if you see, if we had started at the 25-second mark, there's a lot of calibration still coming. So you want to wait for at least 1 minute before you press your start key. Okay, so now we'll go through the entire document. I'm gonna make this like this. So just making sure it's keeping the calibrations as needed, and then you go through the entire document making sure that it's detecting all of those peaks. And you can go a little faster, like so. And so you just do that, and I'm just gonna fast forward this part. Okay. Okay, so once you get to the transition part, because the person is transitioning from a stable condition to something that would is a bit, you're transitioning to standing, sometimes you have an increase in blood pressure or not, or increase in wave. In reality, the pressure is supposed to drop, which we can see from here. Um, but you want to auto scale this so you can still see everything. So control function F3, and this is where sometimes you get that noise. So like that. Let's see. I'm trying to make it a little larger. Yeah. So sometimes you get that noise where it's detecting a noise like that. Can you see? That's not good. And so what you want to do at this point, and it wouldn't affect the other points, right? Because 5% is the least amount of threshold that you need. You want to increase it a little bit. So right now we're going to try increasing it to 7. And so you come to commands, come to find, change the threshold to 7, and do find. and then you do your control F3 and see if it skips that one, because what we want is for it to skip it. Okay, 7 is a bit. Let's see 8. And sometimes it just like you don't, it doesn't, it still keeps detecting the noise. You just have to remove it after you run the macro, and I'll show you how to do that later. Okay, so you can see now that it has skipped that, which is good. And so now we know that we're going to use a threshold of 8 for continuing on. Okay, and so that's always the part where you have a noise, like during the transition. So you want to be careful of that point, which is why you need to go through the entire document and not just do a couple. Because sometimes even in the middle there's noise and it doesn't get detected. So I'm just gonna hold it. Yeah, so you want to go as slow as you want to take you a couple minutes to get to the end, depending on how long your protocol is. So now that is that can be considered a noise, but this is something that we can remove at the during the macro. So we'll just make note of that time when we get there. And that's the end of the document. Okay, so now that you've run through and you've seen where there's potential for noise, you just want to keep that in mind for when you actually run the macro. So next we're going to do is go back to the start, right? And then you want to click like 2 waves before the actual start comment. So you want to make sure you're clicking right where this time is, not on the actual channel, because that wouldn't work. So you want to click where the time is, and you want to get the top of the channel as close as possible. There you go. And then the next thing you do is you come to macro, and then you come to manage. For my template, I have them all set in the library macro. There's supposed to be 3 different ones, so you can run the macro on the ECG, you can run the macro on the BP, and the whole phenomenon we had, sometimes the ECG was inverted, and so we had a macro for ECG, macro ECG inverted. I would upload all of that to the OneDrive just so you can download it onto your template. But I only use the BP macro for my data. And so what you want to do, because we have a threshold of 8%, you have to edit the macro. So you click on macro BP, click on edit, and right now it's set at 6. Usually it's set at 5, but it all depends on what the participant's threshold would be. It depends, very dependent on that. So now for this one I have to change it to 8. And so you have to change it up here in 2 places, and then down here you want to also change it to 8. And it's the only place with the noise threshold. Okay? So those 2 places you want to change, and then you click run, and then you can see that it's running the macro in the background, and it's identifying all of those peaks, and so you just let it run for as long as it takes. And now we have that standing point, and then if you want to continue seeing, you can auto scale the channel, and you want to watch it too, so you know where it's keeping. Awesome. So now that it's run, you want to go to data pad, and you can see it's converted everything to the numbers. And so you go up to the top, and you can see that everything is there. So now we know the blood pressure, we know the cardiac output, we know the heart rate, CPR, stroke volume, all that stuff. And so what you want to do is go back to the chart view, go all the way to the start, like so. And what I like to do, because you have to remove the points of the calibration, because those numbers wouldn't look good. You can see that the cardiac output is reducing really low here, and it's increasing really high here for the systolic and diastolic blood pressure. So you want to remove all the points of calibration, which is why it's important to wait at least a minute before you start data collection, or else you're going to lose a bunch of data points. One thing I like to do to make it easier for me is because the selection time is in seconds, I like to make it easier by changing the chart time to seconds. You cannot do this before you run the macro, or else it's gonna look very the numbers on the data pad wouldn't look good. So you have to do it after you've run the macro. And so you do your time mode. So you right click on time mode and show time in seconds. And so it converts all of that to seconds. Again, you cannot do this before you run your macro. You have to do it after. So the point of this is that now if I go and just randomly click, like I don't have to click, if I hover around this point of calibration, I can read what the time says up on here. So up above the finger pressure. So if I look here, you can see 133 seconds, 129. So now if I look on here, you can see the time up there says 69.8. And so what I want to do is go to the data pad, find where 69.8 is. Also, we can remove this because this doesn't have a start key. Remember, we started one wave before the start key, so you can delete that. And then you want to go to where it's 69.8. So you want to go to the corresponding number, 69.85, very close to it, 0.86. You can see that the cardiac output here says 0.38. That number doesn't look good. And you can see how it has affected the CPER. You can see the C high is very low. And so what you want to do in this case, even though the systolic and diastolic blood pressure looks good, is that you want to delete it. Now, do not worry about deleting it because we have continuous beat by beat measurements. So even if we deleted that part, we are only losing like 3 milliseconds, right? Like 60 to 74, maybe a little bit more than 3, 4-ish, 5-ish milliseconds, which doesn't matter. All you just want is that during the transition, you don't want to remove too much because then that would affect your analysis in MATLAB. And so you have that, and you remove that, and then we go back to the chart view and go and see what this one says. It says 82.6 milliseconds seconds, and then you go to where 82.6 or close to it is, and you can see again that number doesn't look good, and then you delete that. And so you have to do this for the entire document. So you go back to the chart view, see what this is, 94.8. You go back to data pad and you can see this doesn't look good, and you delete that. Again, you're only removing like 1 millisecond data, and you have continuous, so it doesn't really affect the processing. The next one is 115, and you want to delete that. So any point of calibration, even though it doesn't really look too different on the data pad, you want to remove it. And you would do this for the entire document. I'm gonna pause recording right now because the file is going to be too long, but I hope you get the point. So you want to go through every point of calibration and remove the corresponding point away from the data pad. So 185, and then I'll return when we get to that point of the noise. Okay, 185, just this part, and then you want to remove that. Okay, I'm gonna pause for the. Okay, so now I've gotten to the point of the transition, and remember we noticed that there was noise here, and we have to remove that data. And so what we're gonna do is the same thing. I'm going to increase this. And so you're going to see what the data looks like at this point. You want to make sure you're not removing too much. So we just want to remove like this point at the 670 and make sure that the point where it looks like it's a very big drop is also removed. And so 670, we go back to data pad. And so you can see that it's this number. And so we just want to remove that out. We just want to remove that out of, wait, let's just make sure. So it's 669. So that's still very close to 670. It's this one. So you can see how it's 0.87. That doesn't look good, and so we want to remove all of that. Okay. And this one. So you can see that also physiologically kind of impossible to go from 118 to 186. So we also want to remove that. Okay. So we just want to remove numbers that do not look physiologically possible. Another one that we found was around, wait a second, oh sorry. So we just want to look at the numbers here. So the next one we found was 686. So we want to go 686. Here you can see how low that number is. We have to remove that. And so you continue again. So I just wanted to point out what you do when there's so much noise and there's like multiple places where you have the same number. So like the 0.86 that we just took out. Okay. Another thing I wanted to mention, for this column, you can see that it says the blood pressure diastolic dropped to 35. So now you can also notice that the number of time, the amount selection duration here is a bit high. So that doesn't also look like something that we can trust. And so what we want to do first is look at what 676 corresponds to on the LabChart. 676. So it's this point here. It's this point with the noise. So what you want to do is also remove that. Like this part. It seems to be like a noise on this one. I wonder if I can increase that. Yeah, so you can see how it's on the other side. So we also want to remove that 676 just because having a diastolic of a blood pressure of 82/35 isn't physiologically correct, so we also want to remove that. Okay. All right, and so that's what you continue to do for the remaining of the document. So we want to see 686, we removed that already. Okay, and then the next one would be 696. I think we removed that already also. And then the next one would be 725. This one, remove that. And then the next one would be 759. And then you remove that. Okay, and I'll see you at the end of if I find any other noise, and I wanted to point it out. Okay, I am back to that point that we found while we were manually running the macro. So this point of this weird reading here, and so we have to also remove that. And so that's around the 1075 mark. So 1075. So this point, you can see how even though it looks good here, yeah, the numbers here do not look good, and so you want to remove that. Okay, and again, it's only 3 milliseconds data that we are removing, and I think we're almost at the end. Oh yeah, so we're at the end of that. So you also want to make sure that like places that don't have a reading, those columns are always removed because it's at the end, and sometimes the chart. So if you look very closely here, maybe I can expand it a little. You can see that it's out of range for a little bit here, and so we just have to, because then to show that number sign that I just removed away. And so because it's the end also, we don't need too many, so sometimes I like to remove the last 3 because it doesn't really matter. We only need information up to this point. Okay, so now the next thing you do is you go to File, you go to Export, and then you have to create a folder document for that person. And so this is Janelle. And then you want to make sure that the format is following this. So depending on if you have another MATLAB program in the future, I'm not really sure, but according to this MATLAB program, it has to be this particular naming system that you use. So FM, phenometer, person's names, person's ID, whether they are old, middle-aged, or young. This person's actually middle-aged, so I have to change that. I'm using pre-fill for all my long COVID patients and non-fill for all the control subjects, just because the program was created for the frailty study that we did in the lab. F meaning female, if it's a male, it would be M. PT meaning postural transition, A meaning sit to stand, and B meaning lie to stand. Trial 1, just because we had multiple trials before and now we just have one, we just have to keep it as trial 1, and then year, month, and date. And so you can just do the same year, and then I'm just going to change this because this is B instead of A, and you save that. And then save as type would be data pad only as text file. And you save that. Okay, now that that's done, we have to go to the MATLAB. And I'm going to start another recording session for this one.